Hello everyone, I am Uttam Satpute, Professor Electrical Engineering at Dr. D.Y. Patil Pratishthan's College of Engineering, Savankenagar, Kolhapur. Welcome to this video. In this video, we shall deal with the contingency. We shall learn the sensitivity factors in respect of power system security analysis. So in the previous video, we have seen the contingency analysis. What is contingency analysis? Means it is the process of simulating the power system or analyzing the power system for a fault before actually they are occurring. Okay, so we are taking a precaution that if any fault takes place in the power system, then there should not be any interruption or there should not be any violation of operating power system parameters. So this contingency analysis is performed. But when we do contingency analysis, and we have seen also that how contingency analysis is done for generator outage and line outage. Okay, that is that is simulating the power system for generating outage and line outage. And for simulating this power system for this generator outage and line outage, using conventional load flow methods such as maybe Gauss-Seidel or Newton-Raphson method or maybe decoupled or fast decoupled, it becomes very cumbersome and time consuming because uh, they are very lengthy load flow programs. So, uh, but because we want this contingency analysis to be done in very short period of time, very quick analyzing has to be done. So there is another shortcut method. What it is using sensitivity factors that is used for security assessment of the power system. So there are two sensitivity factors that are defined. The one is generator shift factor. It is denoted as alpha Li. And the second one is line outage distribution factor, which is defined as DLI. So let us try to understand this generation shift factor and line outage distribution factor. Here, so this is a generator shift factor. So how it is defined? You can see here it is defined as alpha Li equal to delta FL divided by delta Pj. Let's just understand. Suppose I consider a system. Suppose there is two generators. Say this is one number and two number, and they are connected to a power system. Suppose uh, there is a line over here and there is something line like this and there is one more generator over here. So this is number 3. Let us line the numbers also 1, 2, 3. Okay. Now I have 3 generators. Now here I what notation is used? It is for generator and L it is for the line. Now in the present case, our I there are 3 generators and we have L that is also 3 lines. Okay. Now how this suppose I'm calculating this delta, suppose I'm calculating 1 2. What is delta 1 2? Now I have taken here L equal to 1 and I equal to 2. So what it indicates? It is equal to delta F1 divided by delta E2. So what this means? That is, suppose if if the generator is gone out, suppose if the generator is previously giving 100 megawatt, now suddenly it is out, means it is shut down, it is reduced to zero. So there is a change of minus 100 megawatt. So this delta P2, delta Pg2, now what I am writing here, that is change in the generator power. Change in the generator power. Now the change in the from 100 megawatt it is reduced to 0. So there is a change of minus 100. So delta P2 it is minus 100, and now suppose if this is delta F1 I am writing here, delta F1, suppose here in line number 1, suppose there is 10 megawatt it was flowing, and now because of this outage there is a change in the power, say it is increased to say 15 megawatt. Now there is a change of 5 megawatt, so it will be 5. So this is 5 divided by minus 100, it will be our alpha 1 2. So likewise, we calculate this alpha L1, alpha L2, alpha L, alpha 1 1, alpha 1 2, alpha 1 3, alpha 2 1, and so all sensitivity factors they are calculated. So just try to understand this sensitivity factor. Delta FL, what is delta FL? Delta FL is the change in the power flow in the Lth line. When there is a delta Pg change in power of ith generator. Okay, so these sensitivity factors they are calculated. Now, if FL naught is the power flow in the Lth line before generator outage, then the power flow in that same line after generator outage can be calculated by this equation. So it is here you can see FL equal to FL naught plus delta Li into delta Pg. So FL naught is the flow in the Lth line before contingency, and after contingency means generator outage. So the ith generator is out. Then how to calculate the change in the power flow? This equation we can use. So this is the pre-contingency power flow, and FL is the post-contingency power flow in the L. So this will help us to calculate the change in the power flow, that the power flow in the lines in very in a very uh, shortcut way. Okay. Then second factor, it is line outage distribution factor. It is designated as DLI, and it is defined as DLI equal to delta FL. So please change this. Here it is FI naught. Okay, so in the previous, I will just show that diagram once again. Suppose I will just say, suppose I have this transmission network. I will show this one transmission network. Here I have shown the three lines, say 1, 2, and 3. And now I show some power flow. Suppose here it is 10 megawatt, here it is 5 megawatt, and here it is 8 megawatt. These are the power flow before contingencies. Okay, so here this Fi, whatever I have shown here, Fi0, it is this value. Suppose if I take I is equal to say 2, then my F2 0, that is the power flow, the line flow in the second line before contingency, it is 5 megawatt. Okay, so it is like that. One now, and suppose, and delta FL is the delta FL is the power flow in this line number say 10, then it is FL F1, it is 10 megawatt. So uh, okay, now what I no sorry, you have made a mistake. Now delta FL is the change in the Lth line, that is say number 1. Suppose suppose this line outage, this line is gone out, the second line where the power was 5 megawatt before contingency. Now suppose this line is gone out, and Here from 10, now the power flow is changed. Suppose this power flow is changed to 5 megawatt, then delta FL, the change in the power flow in the second line or first line, it is 5 megawatt, it is minus 5 megawatt, it is reduced by 5 megawatt. So minus 5, that is, make your factor D. Now I have taken L equal to 1 and I have taken it as 2. So D12 is equal to minus 5 divided by 5. So this will give you minus 1. So likewise, the various line outage distribution factors, they are calculated. Okay. So here it is written. Delta F is the change in the line flow in the L line, and here it is Fi naught is the line flow in the L line before contingency. Please make this correction before contingency. Okay. Now, if FL naught is the line flow in the Lth line before fault, then line flow in the same line after outage, line outage, it been given by this equation. FL is equal to FL naught plus delta Li plus delta FL. Okay, so this equation, just I'll repeat it. FL naught is the outflow in the Lth line before fault. Then what will be the power flow in the line after fault, that is FL. It is equal to FL naught plus the change. Now how you calculate the change? It is by multiplying this sensitivity factor into change in this. Sorry, here it is FL naught. Okay, please change this FL naught. So this equation we can use to calculate the change in the line flow. Okay, so in this video up to this only. Thank you very much.